Okay, for our lab today, we have a little projectile launcher. The projectile we're going to launch is this friendly plastic ball. And what I'm going to do is I'm going to put it in here, and I'm going to take this thing and shove it back until it clicks. That's in low power. That's in medium power. I can't go into high power because that would go past the distance this table is going to go. So we're going to stay at medium power. And right now it is at 0 degrees. So it's right at flat. I'll show you a picture of this in a little bit. But so it's going perfectly horizontally, because so far this is all we know how to do, is shove things perfectly horizontally and let them fall. Now this is going to fly through the air, and it's going to hit on the table approximately here. This is usually where it hits. And so I have a piece of paper that's here, and it's taped down to the table so it won't move. And I have a piece of carbon paper. This is something that has stuff that comes off of it easily. And I'm going to put this on the top of this. So when the ball comes along and hits this, ideally it makes a little mark on the paper, and that'll be easier to see exactly where it's going to hit. So we take the trigger and we pull gently, and that makes that exciting movement. And so it came shooting over here, and it made 2 dots. It made 1 dot on the way here, and it made another dot on the way back. And you can tell the difference because the dot on the way in, when it was going real fast, of course it was a darker dot, and the one that bounced back was a little looser. I was trying to put this here so it acts kind of like a airbag, slow it down a little bit. So I'm going to shoot this about 5 times, and we're going to take the average of what's going on here. So wiggled a little bit. You got to make sure it stays right at 0 degrees. There we go. That stopped it nicely. Another beautiful dot. Another beautiful dot. Results here. What we like to see is getting dots that are in a fairly tight pattern, not wiggling all over the place. Okay, so now we're going to take measurements. So I'll move the camera to another spot so that you can see what we're doing here, so we can take measurements. Okay, so this is what your projectile launcher looks like from the side. And of course you see over here from the angle that we're right at 0 degrees. And so that means it's shooting out perfectly horizontally. Now where this little ball right there is drawn into the thing, that is the position where it's leaving the launcher. And so we're going to take some measurements from that spot. So what we want to do is measure the bottom of the ball, because the bottom of the ball, of course, is where the bottom of the ball is what hits the table, and not the middle of the ball. So we're going to measure this to the bottom of the ball, and that's going to be the distance it's falling in centimeters. Of course, we want to switch that to meters, or it's going to mess us up. Sorry, I bumped the button and it stopped recording. So we started our ruler directly underneath the little white ball of where it comes out, and then I have tried to line up the 0 of one ruler with the 100 of the other ruler, and we're coming along and we see our dots. So these are the 5 dots that we're worried about, our 5 shots that we took. And so again, our precision here is just going to be to the nearest centimeter is going to be fine. And so when you look at these, you say, well, I'm just going to kind of average out these 5 mentally, and I'm going to say that's going to be probably somewhere right about in here. So you look at that and you say that looks like it's about 1.49 meters. Would be my horizontal displacement that we had here. So that would be a good data for the horizontal displacement. Once that's how far it traveled through the air as it fell down the vertical displacement that we measured earlier. So we also need to know, of course, how high our table is for the next step, because what we're going to do is we're going to turn the launcher, and when we turn the launcher, we are going to now try and launch it all the way to the floor. So we already know how high it is above the table, but we have to figure out how high is this above the floor. So this should give you a pretty good reading of how tall the tabletop is. So you add this number to the height of the vertical displacement that we measured earlier, and that should help you figure out the total distance down all the way to the floor. So you'll calculate a new time down using that distance. Okay, so now we have it aimed slightly outwards so that it's going toward the floor. It is still at 0 degrees. We are still in medium power, and so it's going to be the exact same situation. We're just now aimed toward the ground. So I have made a slightly larger target, and we're going to fire this puppy. So that hits beautifully over there. Hopefully I can find that ball later. So when we came along, I did this once before, but the recording didn't work. So there you see that there are 2 dots on the ground, one from each of the 2 shots. And so we'll take the average of those 2, which they're right next to each other. So that's a really good average. And I'll take that measurement, and that'll show you how close you are to what you calculated.